Hi everybody, today we're going to be talking about some image processing example, and I imagine this video being the first video of a playlist where I talk about some simple but funny and entertaining image processing applications, some little examples, okay? And at first I assume the length of that playlist will be 3, and this is the first one where I talk about what to do in the coming videos, okay? And as written here, I will be talking about map coloring, okay? For example, um, let's consider this as a map, okay? And you can consider it as a, for example, let's consider that as some map of a country, right? Where we only see the outlines of the states or provinces, right? Something like that. And here we can see there are 8. We also number that, okay? Or there may be the names of the states or provinces, right? And there are here 8, and I just draw that. And this literally will be the first example that we're going to be focusing on, all right? And because this is really simple and it will be easy to explain, right? And okay, now I wanna talk about some stuff. And yeah, agenda here, the agenda of this video is, first we are going to draw an image by hand. Yeah, we just did. There are 8 regions in that um, I guess imagined country. Okay, you can consider it as a country, right? Also it can be some mathematical sets, or you might want to do that kind of, you know, for that type of applications as well. All right, the stuff that you're going to be learning today. And number 2, take a picture of that image. All right, we literally will be taking the picture of that. Of course, since this is an image, I mean this is a digital machine, right? Since this is already in the digital domain, we can just take a screenshot of, or some other means. Or let's say you have a paper and you just draw that 1 2 3 or something, right? You just draw that and you can just take a picture of that paper, right? And this is the basic idea at first. And okay, number 3, pre-process that image using MS Paint type of simple programs, right? For example, I mean, you may be using Apple or something, and you may be having other maybe advanced programs, but it is not important at this stage since the majority of the work will be done on matlab, right? And we only need MS Paint or little kind of simpler, maybe way simpler programs for that too. For example, let's say I literally draw that image and I name the states. For example, let's say there are names of that, you know, seas. Maybe there are some rivers or something, and you like to, just delete them. That type of little um, operations, right? Little processes. For example, you may probably want to delete this, numbers. You may only want to have like 1 2 3 4 5 6 7 8. You may, do some pre-processing in MS Paint or something, and you may wanna get that version of that image. Okay, this is the basic idea, right? And then, and I'm assuming at that stage it will be in PNG or JPEG format, right? And it would be easy for that to import into a matlab, right? In that stage. And number 5, use RGB to gray. Yeah, now we're talking about some matlab functions. Okay, here RGB to gray is the function where, for example, we have a colored image. I mean, even though it may look like a black and white image to you, if it is in PNG or JPEG, it is probably, when we first import it into a matlab, it is in RGB format, meaning it is not a matrix, single matrix. There are rows and columns of it, right? but there are three matrices. Okay, there are R channel, G channel, and B channel. Okay, and I'm not image processing expert by any stretch of the imagination, but I know this. And okay, and RGB to gray is lets you to convert it to a only matrix form where each entry takes value, right? Takes a value and numerical value between 0 and 255, because in that at that stage it uses unsigned integer uint unsigned integer 8, right? This will be the type of that each entry, and we will be looking at that in a moment. All right, and after that we are going to threshold it. Why threshold it? Because, for example, I mean, when we first take the picture and we do enter, right? When we first take the picture, and it may look like a really black and white. You might consider that image just histogram to be as like 0 to 55, right? Like no pixels, but all the pixels are here accumulated here. You may think like that, right? However, what will be happen is 0 to 255, right? Probably, right? There will be some accumulations, maybe here like that. Yeah, probably, maybe like that. And by the way, kind of make a mistake. Yeah, yeah. The global histogram will be looking like that, is what I'm saying. And you may want to set a threshold here. So you may have 0 and 255, right? Like this. You may want to have this like this type of histogram. Okay, and all right, this is the threshold action point. And after that, gray connected. Yeah, gray connected will be the main function where matlab, I guess it comes from the image processing toolbox, right? And yeah, you might want to have image processing toolbox set up. Okay, I'm assuming you already have. And gray connected is a really good function where I will explain what it does. For example, this is 1 and this is 2, right? This is let's say, this is an image. This is an image, right? And this is the matrix where each entry takes the value between 0 and 255, right? Okay. And after that thresholding operation, it will be such that each entry is either 0 or 255, right? And okay, and for example, all right, you are going to supply to function gray connected function, right? The matrix. Okay, when I say matrix, I'm in the matrix form of the image, and it is okay. And for example, the entries are such that this it would be really hard for me to draw or write 255. That's why I'm going to write 1 instead of 255, right? Okay. And this is the other ones are 0, okay? And here this is the matrix, right? And you are going to give some enter rotation where, for example, you consider this as region 1, right? Okay. And you are going to give the matrix 1, the matrix, and 2 x location of an interior point of the region that you are interested in, okay, and to the y location dot dot dot, okay. And for example, this is like 300 and 500, right? 300 rows and 500 columns, right? And you will apply that matrix. I'm going to write matrix 1, and then row number. What is the row number? Let's say 50, okay. All right. And what is the column now? Sorry, what was the, I guess, yeah, 20, okay. First the row number, right? And then column number. By the way, it may be the opposite of it. I'm not 100% fluent with that. Becomes accustomed to this function. If you see there is something, I mean, check the help and documentation of that function. I'm not 100% sure about that. Whenever I type something, especially regarding the image processing applications, I just type documentation, check the documentation if the every if the syntax is correct and if the arguments that I'm supplying is in the right order and all that, right? Okay, this is basic stuff. And after that, yeah, I'm looking at this, and yeah, gray connected, use gray connected. We will be using gray connected. And after that, construct the, yeah, I just said this is not a function, this is not a real function name. I just name an object. This is the name I gave. I will talk about in the next video probably, right? And region ray out tensor, okay. Now we're going to talk about that. For example, okay, now I'm going to draw another matrix. Give me a second. This is 1, right? And this is 2, and this is 3 and 4, okay. And yeah, you use in the previous step gray connected, right? Okay, gray connected function. You just gave matrix 1, matrix, okay. This is some gray image, okay, and then row number, and then row number, and then column number, okay, of the interior, some interior point of a region, okay. And then you will probably say region 1, reg1, okay. And you are going to do the same for region 2 dot 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 and region 10, for example, okay. Gray connected function, again matrix 1, and another, of course, some point that is inside the region 10, okay. And that's why I'm going to call row 10 and column 10, okay. You will manually will be determining this numbers, okay. And to be honest, that is the part where I am sure there must be other smarter way to do that, but this is like the first idea that I just committed, right? I just do that and I get the result, so you should be as well. However, there must be a smarter way. I'm going to admit that. All right. And all right, what's that? What's region 2, for example? This is going to be a binary image, zeros and ones, right? Okay. For example, this is, let's say this is region 2. All right. reg2 matrix. This will give you a matrix. This is a matrix, okay, where the size of that matrix and the size of that gray image matrix, they are same. And yeah, okay, 1 1 1 1 1, yeah, right. Think about every point corresponding to that entry, is 1, and the other ones are, 0, 0, 0, dot, dot, dot. They are all zeros. Okay. Okay. But this is the region 2, right? All right. This is region 2, and region 2 matrix. All right. All right. This is a binary image, and again for region 10. By the way, there is, like, let's say there are some other regions as well, and this is region 10, for example. There are other regions as well, let's assume that. And for rect 10 matrix, this will be a binary matrix, and let me just 10 here, 1 1 1 1. All right, every entry in that section, right, of that matrix is 1, and other entries will be populated by zeros. I just put some dots here, there, but all right. And so what I do here, I just put reg1 and then reg2 dot 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 and reg10, right? Okay, here I assume there are 10 regions, right, that I'm interested in. And by the way, there may be some cases, for example, just a little aside. And for example, this is number 1. Yeah, let's say you want to make this region and this region to be called region 1. You can just do that easily. For example, let's say you just name that region region 1A and region 1B, and you can just sum that. And since they are not overlapping, and since they are just binary, right, there won't be a problem, and you can just name it region 1, right? All right. And yeah, that will be what I called here. What did I call? Let me just remind myself. Region layout tensor. This is what I call. This is like not a some defined terminology or something. And for example, there are 300 rows, right, and 500 columns, right, and there will be 10 elements here. You can just zeros, right? You can just create region layout tensor by doing something like this, and then RLT 1, for example. And let's assume you just created reg1, right, through, of course, gray connected function of matlab, right? And here let's remind ourselves, this will be a 300 comma 500 matrix, binary matrix, right? And yeah, you can just store that, and you can do the same thing for, let me just be more pedagogical, right? reg2, again, you just got that from gray connected function, and dot 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 10. Let's assume there are 10 regions, right? You just got that from gray connected. All right. The only, I guess, the cumbersome part of that application, or that algorithm, I guess, is the determination of the some interior point. For example, this point, 20, 30, for example, right? And if you have like 10 regions or 30 regions even, I mean, yeah, you can do that manually and it won't be a problem, but I assume it would be really painful to do that if you have like hundreds and more, maybe more than 100 regions. And yeah, that is like the, I guess, I mean, at some point, if you do not have to do anything, right? If everything is being done by computer, why do you exist even, right? And that is the, the true story, to be honest. And okay, so we should. What I'm trying to say is that we should be happy where we need to do something. Yeah, otherwise, yeah, we should be like around. Okay. And all right, I talk about what I called region layout tensor. This is an object, right? And three-dimensional matrix. Just it is what it is, right? And number 9, cover the regions as needed. Yeah, this is like after you have that tensor, right? Region layout tensor, it would be a really easy thing to do. For example, there are some things you need to do. For example, I mean, you are just engaging in a task, right? For example, your task is, for example, make, or rather, let me just say, color region 1 yellow, for example, right? And region 2 red, for example, and 3 region 5 and blue, for example, right? There are some, and maybe, I mean, this will be the first task, for example, that you like to, engage. And after that, you may be thinking, for example, what can be the, I mean, more serious projects where I use that, algorithm. And the first that came to my mind, for example, let's say this is a country, 1 2 3 4 5 6, right? This is a country, for example, and there are 3 parties, political parties, A, B, C, and A. Actually, you know what, I'm going to do that something, let's say R, G, B. Yeah, that will be better. R, political party R, and political party G, political party B, for example, right? And you have the data, for example, this is 1 2 3 4 5 6. Yeah, I'm going to give an example right now. Let's say you have some data, region 1 and region 2, 4 5 6. Okay, let's say you have that data, right? And R, B, G, right? For example, this is like 50%, 50%, and 0%. I'm talking about the percentage. And let's say this is like 10%, this is like 80%, and this is, something like that. And according to that, you may want to, I mean, I'm guessing it would be like that, by the way. Yeah, I mean, otherwise there will be reaction in that region. Anyway, and for example, and region name, right? Okay, let's say 90% and 5% and 5%. Of course, there will be, undecided and something. And you may have that type of data, right? And in that, if you first would look at who you should assign to, and here the R, right? R, and R, the value of the R is 90, and for that you can just do something like this. For example, you can use R, G, B, right? Here I'm going to call R normalize percent, right? For example, it is 90%, but you're going to normalize between 0 and 1, right? And you're going to just in that, for that region 1, you will say 0.9, right? And comma 0 and comma 0. You would, I mean, you may wanna do other type of, coloring, but this is the first one I think, I guess someone would do, some would do, right? And after that, for example, for the region 2, right? And you may look at who you should assign, and 60 again R, right? And let's not do region 2, and let's focus on region 3, right? Here 80%, right? 80% and B, right? And that's why here R G B, right? And 80% B we set, and assign 0 R and B, make them 0, and then 0.8, right? 0.8, and you can just color the region in that manner. And this is the first example, or this is the first application, and some example application. And other one would be, for example, you may have a, I mean, today's everybody is talking about some virus, right? And for example, let's say this is another country, right? Again, region 1, region 2, and region 3, right? And here this is the case numbers, for example, and cases per 100,000 people, right? And let's say 1 2 3, right? For 1 2 3, for that case numbers, right? For region 1, right, you have the number 10, for example. For region 2, you have the number 50, for example. And for region 3, let's say you have 1,000, let's say, right? And in that case, you would, and you would also have something like this. For example, you would like to make the region where the number is really low blue. Again, people would do that, right? Blue makes you think it's safe, I guess. And for if the case is number is really high, you may want to make that R. So for example, region is num vector, right? You may have something like this, some numbers, right? And you would determine the numbers. You would map the numbers to a RGB, right? Some RGB values, right? Again, it depends on how you wanna map that. I mean, you can easily map, for example, the lowest to blue, right? And there will be an example. We're going to be talking more about this, and but it's not hard. It is actually very easy. The the most cumbersome part of that application is to determine if the region number is really high, like 100 or something, right? And you want to have some location of an interior point, and you may want to do that manually, right? And that is the most cumbersome part. Other than that, it's really easy. And I will try to find how should I share the codes with you guys, right? And I'm checking if there is anything left. All right, there are basically 9 steps. Of course there will be less than that, I guess. And okay, yeah, right. And thanks for watching. See you in the next video.